This week shouldn't be too difficult. It's just going to take molarity and put it in the context of stoichiometry. There won't even be any limiting or excess reactants. We'll save that for next week. So what I'm going to do is we're going to take a look at this solution stoichiometry, and you'll get a worksheet, and it has this at the top. Okay, and it gives you a few handy little tips, like always remember when you're dealing with molarity, capital M, you're always going to rewrite it as moles per liter. Also, anytime you're given milliliters in the question, you'll want to convert it into liters, which is going to allow you to use it in this conversion, or to use that conversion factor to convert. As with any stoichiometry question, you should always be writing down your known quantity and your unknown quantity. And the only part where this gets tricky is that you are going to have some quantities where you have liters, which are gases, and you might have liters, which are solutions. And you have to be careful about which one you have. So I'm going to recommend that whenever you write down liters, that you write down either gas or solution. You can write down aqueous if you want to. Okay. So I think probably the best way to go about doing this is just to start with a couple of examples. If you have just joined us, we are taking a look at solution stoichiometry. This little thing I've got in front of you, can you guys all, have I shared my screen with you? Always, I need to check, right? Because sometimes I forget.
Yes, you have.
Yay, good stuff. Okay.
Yeah, I can see it as well.
Excellent. All right, so if you haven't put your name into the chat yet, if you could please do that. I know a couple people just joined us. And now, what is wrong with my, there we go, that's why. Okay, so we are going to do an example here. What volume of 2.6 molar HBr must be reacted with magnesium metal to produce 2 liters of hydrogen gas at STP. Okay, so we're going to start with this little map that we have up here, and we're going to identify what our known is and what our unknown is. So take a look at this question and decide who is the unknown in this question. Type it into the chat if you think you know. What is the unknown in this question? Okay, I got one person venturing a guess. Let's take a look for our question word, okay? Here's our what. So we are looking for what volume, and what are we looking for the volume of? Yeah, we're looking for the volume of the HBr. Yes, we have some information about the HBr, but remember, this is going to be a conversion factor. So even though we know some information about the HBr, it is still our unknown. So we can fill that in over in our unknown box over here. So our unknown is the volume. In this case, I'm going to say liters of HBr. Now, do you remember I said one of the things you want to do is whenever you have liters, you're going to make a note if it is a gas or if it is a solution, aqueous. Do we have a gas or do we have a solution here of our HBr? Is HBr a gas or is it a solution? Yes, it is a solution. How do you know? Well, why did I write gas? Because I'm silly. It is a solution. How do you know it's a solution? Because it says molar. Anytime you see the word molar, you know it is a solution. And what that means is that if you take a look up at the top right-hand corner, you are going to be able, there's two conversion factors that involve liters. There is this one here, and that one is only used for a gas. And then there's this one here, and that is only used for a solution. So it's important you know which one you're going to use. So in this case, when we are converting into our unknown, we will be using the molarity of the solution as our conversion factor. Okay. In this question, what is our known substance? Yeah, those 2 liters of H2 gas. So our known substance is 2 liters of H2. And I think it should be pretty obvious from the fact that there's a G beside it that this is a gas. So we're going to use the 22.4 liters for a conversion factor there. And anytime you do stoichiometry, in the middle you always have the moles. So we're first going to convert into moles of our known. So we're going to be finding moles of H2. And then we're going to convert and we're going to find moles of our unknown, which is the HBr. And then in our final step, we'll be finding our liters of solution of the HBr. So this will be a 1, 2, 3-step conversion. So we should have 3 multiplication signs in our conversion chain. Okay, so we want to find the liters of HBr solution. That's what we don't know. And we are starting with 2.0 liters of H2. I'm going to write gas so I don't forget that I'm dealing with a gas. And we are converting into moles of H2. So we need to cancel the liters of H2 and find moles of H2. What conversion factor do we use there? Am I recording this? Yes, I am. What conversion factor do we use here?
22.4 liters.
22.4 liters per 1 mole, yes.
At 101.3 kilopascals, that is.
Yes, we are at STP though, so that's a good thing. Okay, so there we go. Now we have our moles of H2, so we've made it through step 1. Next, we're going to do step 2. We want to find moles of HBr. So we need to cancel the moles of H2. And we need to find the moles of HBr. Where do we find the conversion for that?
In a balanced equation?
In the balanced equation, absolutely. Do we have a balanced equation? No, we don't.
Yet.
If I am not kind enough to give you a balanced equation, you are going to have to right one. So I'm just going to scooch down here. We are reacting HBr with magnesium metal, and one of our products is going to be hydrogen gas. What is our other product going to be?
MgBr.
MgBr. Very, very close.
2.
MgBr2, yes, because Mg is 2 plus and Br is -1. So we take a look at that, and all we need to do to balance it is to put a 2 in front of the HBr. So that means we have a 2, and in front of the H2 there's a 1 that we haven't written. So we have 2 moles of HBr for every 1 mole of H2. Going back up to our little map of the problem. Now we've found moles of HBr. Now we need to convert, and we've done our second step, we need to do our third step and find liters of HBr solution. So we're wanting to find liters of HBr, and we need to cancel moles of HBr. What conversion factor do we use to convert between moles and liters when we have a solution? What conversion factor do we use to go back and forth between moles of in a solution and liters?
Isn't it
Moles
the
per
2.6?
2.6.
It is the 2.6. Yes, we use the molarity.
That's right.
Absolutely. Okay. And that's why it's important. One of the other things that I said to do that I didn't do was always rewrite molarity as moles per liter, because that way you'll see that it is a conversion factor. So in this case, we have our 2.6 moles of HBr per liter is our conversion factor there. I should have left more room, but I did not. Okay, so 2.6. Uh-oh, what did I do?
Wrong way.
Wrong way. I don't have 2.6 liters per mole. I have 2.6
Moles of HBr
moles
per
of
1 liter.
Exactly. All right. And we are going to throw that into our calculator. And we have 2 divided by 22.4 times 2 divided by 2.6 is, and we get 0.0687. And our unit that we are left with is the liter. Everything else is canceled out. So that's going to be that many liters. Now, this would be a perfectly fine way to leave your answer. Does this look like a number that would be better written in liters or better written in milliliters?
Miss Spence, what about significant figures?
Oh yeah, we need to deal with that.
Make sure you
too.
check it.
Yeah, we need to check our sig figs. Okay, so let's start by checking sig figs. We've got 2 sig figs there, 3 there. We've got infinite sig figs, infinite, and 2. So we want to go to 2 sig figs. So that will be 0.069 liters.
You got it.
Yeah. And I will let you know that nobody would give, like no chemist would walk around and say 0.069 liters of solution, because when you go to measure that out, you're probably going to use a 100 milliliter graduated cylinder. So it would make a lot more sense to write it as, move our decimal place 3 places, 69 milliliters. Okay? Do you have to do that last step? No. Is it a good practice to get into? Yes. Think about how you would go about measuring it and be like, am I going to take out a 0.1 liter volumetric, or sorry, a graduated cylinder? No. Okay. Are we ready for another one? And if we're not, we're doing one anyway. Okay. Okay. If 15.2 milliliters of strontium hydroxide reacts with 10.9 milliliters of 0.3 molar H3BO3, which is boric acid. What is the molarity of the strontium hydroxide? Okay. Start by finding your unknown. Usually the easiest to start by finding that because you've got the what or the how many. Who is our unknown?
We want to find the molarity of the strontium hydroxides are unknown.
Exactly. So even though we have some information about the strontium hydroxide, what that means is that we're probably going to have to use that information to find the molarity. And so we could say that our unknown is the concentration of strontium hydroxide, and the formula for strontium hydroxide, of course, is SrOH2, because strontium is 2 plus and hydroxide is -1. So we want to find, and molarity is measured in what? What's the unit of molarity?
Molar?
Molar, or
Moles per liter?
moles per liter. And I'm going to write it as moles per liter because that way it just keeps me, on track. So we want to actually find the concentration, the moles per liter of SrOH2. Okay, in this question, who is our known substance? Who is the known substance? What can we find moles of?
Sorry, can you repeat that?
What is our known substance in this question?
15.2 milliliters of strontium.
Okay, that is a good guess, okay, because we do know something about the strontium, but we already know that strontium is our unknown. It can't be both our known and our unknown, which is why I'm going to have you find the unknown first. Once you've said strontium hydroxide is my unknown, I know that it cannot also be my known substance. So if it's not strontium hydroxide, yeah, Quentin, it is our H3BO3 because we know a lot of information about our H3BO3. We know that we have 10.9 milliliters. And remember, rewrite your milliliters as liters. So that will be 0.0109 liters. We've moved our decimal place 1, 2, 3 positions. Okay, did I do that right? No. It's hard to write on the side of the screen. It doesn't like it. 10.9 milliliters. And now if we move our decimal place, 1, 2, 3, There we go. That's better. Okay. So for our known substance, we know that we have 0.0109 liters. 0.0109 liters. And we also know that we have 0.300 moles per liter. Oh, 0.300 moles per liter. Okay, and that's nice because you can see that if we have liters and if we have moles per liter, we will be able to find the moles. Okay, and the substance there is the H3BO3. So I'm going to write that here, H3BO3. Now we have some liters kicking around here. Is our H3BO3 a solution or is it a gas?
It is a solution.
It is a solution. So we will not be using 22.4, okay? Also, strontium hydroxide. We're going to have some liters over here. Is it a solution or is it a gas? Strontium hydroxide. Yeah, it's also a solution because we're going to be finding the moles per liter. I would have had to have told you that it was a gas, and I would have mentioned STP in there somewhere, okay? So yeah, it is a solution. Good stuff. So nowhere in this question are we going to use 22.4 unless the word gas or STP shows up in the question. Do not use 22.4. Okay, so our known substance is the H3BO4. So let's start by finding moles of, or BO3 rather, H3BO3. Our unknown substance is SrOH2, so we're going to find moles of SrOH2. Okay, and well, it looks like we can get going on that. Good. So we want to find the concentration of SrOH2. Remember, that's how we say concentration of. And that's going to be the moles of SrOH2 per liter. Okay, now we are starting with our known substance, which is 0.0109 liters. Maybe I'll put it in blue since that's our known substance. 0.0109 liters. And because this is stoichiometry, I am going to put the substance now. This is H3BO3 times, we want to find moles. Step one is usually find the moles. So cancel your liters.
Makes sense.
Yeah.
Why do we use the 0.01 instead of the other thing?
Instead of the 15.2?
Yeah.
Yeah, okay. So let's look at what's all attached to each other here. We have 10.9 milliliters of the 0.300 molar H3BO3. So this is milliliters of H3BO3, and this is 0.300 molar H3BO3. I have 15.2 milliliters of strontium hydroxide, so I can't use the concentration of the acid to find the concentration of the strontium hydroxide. Does that make sense?
Yeah, I don't know why, why don't we use the molarity? Like the 0.300? Like, why do we have to use 10.9?
Oh, we are using the molarity though. We just haven't written it down yet.
Okay.
You
go
could write,
backwards.
you could write it first. It wouldn't matter because we have 0.300 moles per liter. So that's going to be 0.300 moles of H3BO3 per 1 liter. And you could have written these two in the other order, but we don't usually do it that way because usually we do it like that. But it would be totally fine to do it the other way as well because A times B is the same as B times A.
Okay.
Okay?
Okay.
Yeah. Okay, so now we have our moles of boric acid, and we want to cancel the moles of H3BO3, and we want to find, let's go back up, we want to find moles of strontium hydroxide. Okay, what do we need to do that?
Do we have a balanced equation first?
We need a balanced equation first, so good. Yeah, let's do that. We have balanced equation. I'm going to leave some room because this is going to take up a bit of space. We have H3BO3 plus SrOH2 are our reactants. What kind of a reaction is this?
A neutralization.
It is neutralization. We have our hydrogen and we have our hydroxide. So when we predict our products, we are going to get a salt, and our salt is going to be made of strontium 2 plus. And what is the other half of the salt going to be?
BO3.
BO3. You won't find BO3 on your table of common ions. However, you know that you have 3 H pluses. So what does the charge on BO3 have to be?
3 plus.
It has to be, 3 minus. Yeah, I knew what you meant. Okay, and so our formula then would be SR3BO3 2, and then of course our other product is water. Okay, now this is not balanced, so let's balance it by, well, one thing you can do is you can say I want 3 strontiums, so 3 strontiums. I want to have 2 borates, 2 borates, and guess what? That's going to give me 6 hydrogens. It's also going to give me 6 hydroxides, which will mean that I need to have 6 waters because every water is a hydrogen and a hydroxide. Okay, so there is our balanced equation. So we want the coefficient for the strontium hydroxide, and we want the coefficient for the boric acid. That is a 3:2 ratio. So that is a 3:2 ratio. All right, and then for our final step, this might be a little tricky. I'll show you 2 ways of doing it, okay? We've gotten to this point. We wanted moles of SrOH2 on the top, and we have moles of SrOH2, okay? Now, we want to have liters on the bottom, and people always want to do fancy things and have, like, I don't know what they want to do, but you already have your moles on the top. You don't want to have anything else on the top because otherwise it would mess up the fact that you've got your right unit already. You have the correct unit. So just stick a 1 up there, okay? And you are going to put that over, what do you want on the bottom? You want to have liters, okay? So you want to have the liters, and that's going to be of the SrOH2. Let's go back to our question and see if we can find the liters of SrOH2. Liters of SrOH2, oh, we have milliliters. So if we move our decimal place 1, 2, 3 positions, that's going to give us 0.0152 liters of SrOH2. Okay, so we're going to go over here and say we have, I didn't leave myself enough room, 0.0152 liters of SrOH2. So let's now shrink that a little so we can see it all in one place. There we go. Okay, I'll make it bigger again in a moment. So take that and chuck it into the calculator. We have 0.0109 times 0.3 times 3 divided by 2 divided by 0.0152 equals 0.333, and our unit, all we have left is the moles and the liters. So that is moles per liter. Is that what we wanted? Yes, it is. We wanted to have moles per liter. Would we like to see a different way to do that?
Wait, hang on. Is it like on my calculator?
Oh, did I calculate it wrong?
Isn't it supposed to be 0.322697368?
Oh, it's totally possible I plugged in something wrong. Hang on. 0.0109 times 0.3 times 3 divided by 2 divided by 0.0152 equals, oh yeah, 323. There we go. Is that better?
That makes much more sense.
Excellent. Okay. Would we like to see another way of doing it, or are we happy enough to just have that little one with nothing and nothing, no unit attached? Are we okay with that?
I think we might be okay.
Okay. All right. So is that a yes, we'd like to see it, or a yes, we're all right? Okay, yes, we're all right. Okay. If anybody does want to see it, you can stick around for a few minutes after we're done the main lesson, and then you can go. Now, how are we feeling about these types of problems? I can do another example, or I can let you go and you can practice it.
You do another example?
I sure can. All right, let's do one here.
Wait, Miss Benz.
Yes.
Before you start,
Yep.
is there a worksheet on this as well?
Yes, there is.
Do you know where it can be found?
I will just pop it up onto Teams right this second. I hadn't published it yet because I haven't made the answer key. However, I will make the answer key as soon as I'm done this. So if you want to get started on it, say for example, you could do that. Just one second here, assignments. There we go. There we go. Student 7, next. And there is also this week a molarity quiz on Schoology that you can do to test your knowledge of what you did last week. Oh, go back. And I want to go to drafts. And I want to go to solution stoichiometry, add resources, upload from this device, Dropbox, Chem 11. Come on, Chem 11. Stoichiometry, solution stoichiometry. There it is. Okay. I think I got the right one. Anyway, it's up there now. I will repost it with the one with the answer key as soon as I'm done, but that should be enough to get you going. If you are done at this point and you think you have enough, you can go and do the Schoology quiz and go and do the practice solution stoichiometry worksheet, but I will do another example if you want to hang around and do that with us.
I pretty much understand the concept, so am I good to go for now?
Sure.
If you
No,
want?
I have no problem with that. Okay.
Yeah, I'm pretty much good for now because I pretty much understand the concept.
Sounds good. All right.
Thank,
See you later,
thank you
Aries.
thank you very much for your help today. Have a good
You're
day.
very welcome. Anyone else who wants to leave, that's totally fine as well. I will not be offended. You don't have to stick around.
All right, have a good day.
Okay, bye-bye.
All right,
Bye,
bye-bye.
Aries.
Where, Maddie?
Okay, let's try an example. Number 3. How many liters of sulfuric acid would be required to react completely with 3.00 grams of lithium hydroxide? You're welcome. Okay. So if we do this one, how many liters of sulfuric acid? That is our unknown because it's got the how many. Okay, and we need, let's see, that would be liters. Sulfuric acid. Do you remember if you have an ic acid, that goes with what kind of an ion? Ic acids, those go with ate. I ate something icky, yes. Okay, so that would be sulfate, and sulfate is SO4 2 minus, and that means that our formula is going to be H2SO4. Okay, so our unknown is liters of, oh, why am I putting my unknown on the left-hand side? I want to put it on the right-hand side because that's what I'm working towards. So my unknown is the liters of H2SO4. Would be required to react completely with 3 grams of lithium hydroxide. So we are starting with our known is 3 grams of lithium hydroxide. Lithium is Li plus, hydroxide is OH minus, and so we have 3 grams of LiOH. Now, what do we convert grams of lithium hydroxide into in order to get eventually to our liters of H2SO4?
Could you repeat the question?
Oh, yes, certainly. What is our first step going to be? What are we going to convert grams of lithium hydroxide into in order to get closer to finding our unknown? Yeah, we're going to convert it into moles. So we want to find the moles of LiOH. And we actually have a problem with this question. I forgot to give you a piece of information. I needed to tell you the molarity of the sulfuric acid, and that is 0.200 molar, because otherwise you're going to be out of luck in getting to the liters over here. Once we have moles of lithium hydroxide, what will we convert to? We convert from moles of lithium hydroxide to, yeah, moles of H2SO4. That's correct. Moles of H2SO4. Now, what conversion factor do we use to go from grams to moles in our step number 1? What conversion factor do we use to go from grams of lithium hydroxide to moles of lithium hydroxide? Yeah, we're going to use the molar mass. Excellent. What are we going to use to go from moles of lithium hydroxide to moles of H2SO4? The balanced equation, yes. And finally, what are we going to use to go from moles of H2SO4 to liters of H2SO4? Molarity, that's right. We're going to use the molarity, the moles per liter. Excellent. All right, so now we've got our question set up to do. And let's work through it then. We are starting with, we want to find the liters of H2SO4. No, not times. That's what I'm trying to find. Oh dear. Okay. Wake up, brain. Let's go. There we go. Grams of lithium hydroxide. That's better. We're going to use our molar mass to convert from grams into moles. And the molar mass of lithium hydroxide is, let's see, what's molar mass of lithium? It is 6.9. So we have 6.9 plus 16 for oxygen plus 1 for hydrogen is 23.9. 23.9 grams per 1 mole. All right. Grams are gone. Now we have moles of LiOH. We are going to use our balanced equation to convert into moles of H2SO4. So moles of H2SO4, moles of LiOH. And we need a balanced equation for that. So we have LiOH plus H2SO4. I'm just going to give you the products for this and not make you think about it. It's going to be Li2SO4 plus H2O, and we need to have 2 Li's, so let's put a 2 there. That's going to give us 2 hydroxides. We already have 2 hydrogens, and what that means is we're going to need 2 waters being formed at the end. So we have a 1 to 2 ratio there. So there is a 2 in front of the LiOH and a 1 for the H2SO4. And finally, we want to find the liters of H2SO4, and I didn't check to see if it was a gas, but nowhere did I see it was a gas, and you guys correctly identified that we would be using molarity there, so that's great. So let's cancel our moles H2SO4 and find our liters. Now let's go up here and see what it says about that. It says we have 0.200 molar H2SO4. So we have 0.200 molar H2SO4. Do I put the 0.200 on the top of this conversion factor, or do I put it on the bottom of this conversion factor? Yeah, that 0.200 goes on the bottom, absolutely. 0.200 moles per liter, and that is it. I think we're good at that point. Boom, 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 boom. And we get, let's see, 3 divided by 23.9 divided by 2 divided by 0.2. equals. And we get 0.314 liters. Okay. How are we feeling? Would we like any more examples?
Miss Barnes, I have a
Yeah.
question. So I don't really understand how did we get the 0.200 mole H2O per liter?
Ah, okay. Excellent. So that came from here. So anytime you see, if you were to see, and that's from the question, and I forgot to write it in the first time, so you might have missed it when I chucked it in there later. That's probably where. Is that what happened?
Yeah.
Yeah, okay.
Okay.
Yeah, I forgot to write it in when I first wrote the question. Oops.
Okay.
Yeah. Okay, so you have a quiz and you have a worksheet this week. They are both listed. Yeah.
I have a question.
Yes.
Do you want us to do the molarity worksheet B?
Do you know what? You can do it for extra practice. Like if you do the quiz and you're like, oh shoot, that went
okay.
badly. You can do it for
Okay.
extra practice. Yeah.
Okay, thank you.
You're welcome. All right. So you guys have yourselves a great week. Don't forget there's a quiz and a worksheet. They should be on the assignments page. And have a great week.